here we are day 5 in unit 9, and today we're going to talk about polynomial long division. And what's helpful here is to go back and look at what long division is that we learned in 4th grade and what it looks like. So if you remember, 1,519 divided by 7. The first thing that we always want to do is we want to check to see how many times 7 goes into 1. It doesn't go in at all, so we say, okay, how many times does 7 go into 15? It goes in twice, and over here, yes, I know we know how to multiply 2 times 7, but I want to be very consistent here. So 7 times 2 is 14. We then multiply these and then take away the 14. 15 minus 14 is 1. And then you bring down the next term, or 1. Then you say, okay, how many times does 7 go into 11? And it goes in once, so 1 times 7 is 7. You subtract that amount, and you get 4. Bring down the 9. 7 goes into 49 7 times, right? So 7 goes into 7 times 7 is 49. Then you subtract the 49 and get 0. So if you remember, that's long division. So 1,519 divided by 7 is 217. Or we could even write it as 1519 equals 7 times 217, right? If I can divide the 7, then I certainly can multiply 7 times the quotient to get the original value. So how does that apply for polynomial long division? Well, the thing is it's exactly the same thing. So with polynomial long division, now we're going to be looking at something like this, where the process is exactly the same. There's a little extra baggage that we're going to be bringing along with us, but it's really the same thing. So we set it up the same, right? So we have our original value. We're going to divide by x plus 6. So we have x plus 6. How many times does it go into 2x squared plus 15x plus 18? Well, the plus 6 here is just along for the ride, okay? The x is going to behave like the 7. So you're going to say x times what is going to give me the 2x squared, right? Because that's the first placeholder. So x times, well, 2x. And then I would take the 2x and I'd put it here, right? Because this is the question you ask every single time. How many times does x go into 2x squared? So then you take 2x, right? And you multiply that by x plus 6. Okay, so 2x times x is 2x squared, and 2x times 6 is plus 12x. Oops. Okay, now we're going to subtract that amount, just like we did up here. We multiplied 7 times 2 and got 14. We're going to subtract that amount. So 2x squared plus 12x. 2x squared minus 2x squared is no more x squareds. Don't forget, we're minusing everything. So it's 15x minus 12x is 3x. Bring down the next term. Just like up here, when we got 1, we brought down the next term. Then you're going to ask the same question. What must I multiply x by to get 3x? And that answer is 3. So over here I can write 3 times x plus 6 equals 3x plus 18. Right? 3 times x, 3 times 6, 3x plus 18. I'm going to subtract that amount here. 3x plus 18. 3x minus 3x is no more x's, and 18 minus 18 is 0. So 2 2x squared plus 15x plus 18 equals x plus 6 times 2x plus 3. And you can always check that too, right? You can multiply these out. You can also take this and put it into Desmos, and take this and put it into Desmos, and see if they're exactly the same graph. Okay? So, most of the time you're just going to be asked to write 2x plus 3 as your answer. So, let's continue. We've got 1,518 divided by 7. Well, seeing as we know that 1,519 goes, 7 goes into, what am I saying? 1,518 is not divisible by 7 because 1,519 is. Let's see how this goes. So 7, 15. 7 goes into 1 0 times, but 7 goes into 15 twice. We subtract the 14 and we get 1. Bring down the 1. 7 goes into 11 once. Subtract the 7. Now, 11 minus 7 is 4. When I bring down the 8 though, 7 goes into 48 6 times, right? And we get 42. I have a remainder of 6. Now, if you continued on using decimals, it would be different, but I don't want to practice that right now because I don't necessarily need it. What I need to do is write plus 6 over 7. I take the remainder and I put it over the divisor. Okay? Because technically, it doesn't go in a full one more time, right? Only 6/7 of it. But I can apply that exact same principle when I do one like this. So here, x minus 3, how many times does it go into x squared plus 2x minus 5? Well, the process is the same. X times what gives me x squared? X. So x times x minus 3, right? The negative 3 is just along for the ride. And that's x squared minus 3x. Now watch your signs, okay? So we have x squared minus 3x. X squared minus x squared is no more x squareds. But here we have 2x minus negative 3x is 5x. And then we bring down the negative 5. Now, how many times does x go into 5x? Well, 5 times. So 5 times x minus 3, right? And that way I'll get 5x minus 15. Over here, don't forget to write your minus and then a parentheses. 5x minus 15. So 5x minus 5x, that's no more x's, but negative 5 minus negative 15 is positive 10, right? Negative 5 plus 15. Now, since we have a remainder, we want to go up here and just write plus 10 over x minus 3. And that's our new answer. Okay, so yes, it doesn't go in perfectly. We would say that x minus 3 is not a factor of x squared plus 2x minus 5, but we still can show the long division just with a remainder. So let's move on to this one here. Sometimes we'll have coefficients out front. That's totally fine. The process is exactly the same. So we want 2x squared minus 23x plus 17 divided by x minus 10. So we have x minus 10. How many times does that go into 2x squared minus 23x plus 17? So you say, okay, x times what is going to give me 2x squared? Well, 2x. So over here, I'm going to write 2x times x minus 10. That's 2x squared minus 20x. So over here, 2x squared minus 20x. And the 2x squareds cancel. but negative 23x minus negative 20x is negative 3x, right? That's really saying negative 23 plus 20 because of the double negative. Then we bring down the plus 17. Now I want to say, how many times, or what must I multiply x by to get negative 3x? Well, that's negative 3. So negative 3 times x minus 10 is negative 3x plus 30, right? Yes. Minus that exact amount, negative 3x plus 30. So negative 3x minus negative 3x is no more x's, right? This turns to positive. 17 minus 30 is negative 13. So up here, I'm going to write plus negative 13 over x minus 10. Okay? Couple more. So when you're dividing, so far, every single example that we've done, right, whenever we bring down terms, it's important to notice that we're taking into account all the place values. For example, if I had 1508 and I started to divide that through by 7, right, I'd get 1, and then I would bring down a 0. Well, when you're doing polynomial long division, it's important to make sure that every x value has a place. So notice this goes from x to the third down to x. We have to account for the fact that x squared is not there. So really, another way to write this polynomial is 2x to the third plus 0x squared minus 3x plus 5. We have to write in that 0x squared because it's a placeholder, right? I wouldn't say that 107 is the same thing as 17. That 0 is important. So when we divide, we're just going to divide this guy by x minus 3. Essentially, we're asking, is x minus 3 a factor of the larger polynomial? So x times what gives me 2x to the third? I'm going to say 2x squared. 2x squared times x minus 3, 2x squared, 2x to the third, 2x squared times negative 3 is negative 6x squared. I'm going to subtract that amount. I get 2x to the third minus 6x squared. Watch your signs. 2x to the thirds cancel. 0 minus negative 6 is 6x squared. Bring down the negative 3x. X times what gives me 6x squared? Well, I'm pretty sure that's 6x. So 6x times x minus 3 is 6x squared minus 18x. Subtract that 6x squared minus 18x all over. Well, these cancel, right? You get negative 3x minus negative 18. So that's really negative 3 plus 18, or 15x. Bring down the 5. X times what gives me 15x? 15. So 15 times x minus 3 is 15x minus 45. I'm going to subtract 15x minus 45. 15x minus 15x, no more x's, but then 5 minus negative 45 is 5 plus 45, or 50. So up here I would write plus 50 over x minus 3. And this is our answer. Okay? So one more very quick example. This was a Regents exam question, so this is about as tricky as they get. When the function p of x, aka p of x is this original guy, right? That's all that means. The original is divided by x minus 1, okay? So here's the divisor. The quotient, aka the answer, is x squared plus 7 plus 5 over x minus 1. Okay. Find p of x in standard form. So if I divided and got an answer, how do you check it? Well, you just multiply, right? So if I get 15 equals 5 times 3, right? Didn't that come from, or couldn't I have restated it as 15 divided by 3 equals 5? Well, that's all they're telling us to do, is to go in the opposite direction. So they've given us this. We need to just turn that around and multiply. So instead, I'm going to take x minus 1 and multiply it with x squared plus 7 plus 5 over x minus 1. Okay? And when you do that, essentially, you're taking x minus 1 and multiplying it to every term individually. So this is like saying x squared times x minus 1 plus 7 times x minus 1 plus 5 over x minus 1 times x minus 1. Okay, so here I'll get x to the third minus x squared plus 7x minus 7. The x minus 1 and the x minus 1 here cancel, and I'm just left with plus 5. And then I'll have x to the third minus x squared plus 7x minus 2, because those are the only two things that will combine. Okay? So if you have any questions, I will be posting some supplemental videos about polynomial long division on the Google Classroom. This is a very difficult skill, so please let me know if you have any questions. Have a great day.